Manufacturing and industrial environments provide their own unique challenges for wireless communications. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. This is where we come to discuss those challenges, share ideas, and help one another out. My name is Scott McNeil, and welcome to the Industrial Wi-Fi Shop. Welcome to the Industrial Wi-Fi Shop podcast. My name is Scott McNeil, and with me for the inaugural episode of this podcast is Justin Shade of Phoenix Contact. Justin, a little blurb about yourself, sir.
Yeah, thanks, Scott. Thanks for having me. Like Scott said, my name is Justin Shade. I'm Phoenix Contact, and my role there is an automation sales engineer. So I support customers with selecting industrial automation components. I've been in Phoenix for about 18 years with various roles. My previous role was the product manager for marketing within Phoenix for industrial wireless components. So responsibility there was to help launch new products, market industrial wireless products, support and sell industrial wireless products. So I think that role was kind of the basis of this conversation today with you, Scott.
Absolutely. And, thanks again for taking the time and coming on to hang out with us. Today I thought we would kick off the show by talking about the need for wireless assessments for industrial wireless projects. There's so much that goes on in the industrial environment in general that it's hard to keep track of it all. And if you're a controls engineer or an OT guy whose job it is to deal with all of that on top of your controls responsibilities, there's a lot you just don't know. It's not your background, you weren't trained in it, and so you need a professional to come in and assess the situation and really give you a good eye of what's going on in your environment, so that whatever project it is that you're looking to do wireless wise will be both successful in the short term and the long term. And really, to kind of kick it off, I want to talk about the environmental factors. When you compare environmental factors from industrial manufacturing versus your standard enterprise deployment, it's a night and day difference. You have indoor and outdoor in an enterprise environment, but your indoor and outdoor is going to be different. And there's actually kind of a strange combination of indoor and outdoor. Indoor and outdoor both, as far as manufacturing is concerned. Sometimes it's clean, sometimes it's very, very dirty. You have a lot higher temperatures in general that you have to deal with, humidity, dust. I come from a background of pulp and paper, which in general is a very dirty process. And it's interesting because in the shipping, receiving areas, a lot of times it's that kind of hybrid area that's both indoor and outdoor. It's got a roof and it's got some walls, but otherwise it's open to the weather and external forces. So while you might be protected from direct sunlight and direct rain, you still have all the heat, all the humidity, all the dust that kicks up. So it's an interesting combination of effects that you get.
Yeah, and like you said, like an indoor environment is still an outdoor environment. So you look at the enterprise or the commercial areas, and your temperature controlled, your humidity controlled. You're in a nice, controlled environment. You go to a warehouse, you go to a loading dock. You may or may not have heat, may or may not have air conditioning. The temperatures are changing with the weather outside. You mentioned, loading docks. So you have trucks coming in that are loaded with snow, with mud, with rain. You have things transporting through those facilities. So if it's a train cart going through, you have things that are bouncing off those cars and hitting, control cabinets, hitting the material that's there. It's not a clean environment. So you're dealing with a lot of different things that you typically don't deal with, again, in a building, right? You're dealing with all the elements, all the different things that bounce off and fall off moving stuff.
Well, and to take that a step further, the actual manufacturing environment, whether you're making cars or you're producing paper, you have the stock that you're producing as it rolls through the machinery. You have the machinery itself,
Mhm.
which that alone provides its own unique set of challenges because in the average office environment, you don't have to deal with mass amounts of reflection and refraction of your signal. I mean, you look at attenuation for absorption through walls and ceiling and stuff, but it's a different animal because everything is metal and steel and conduit, and it's a different challenge when you think about it from an RF standpoint. So not only is it your heat and your humidity and dust and let's look at dust for a second. Even dust is subjective. You take again pulp and paper, and it's wood pulp. It's pulp dust. It can be thick and insulating to trap heat.
Hmm.
But if you're at a metal processing facility, that dust could be loaded with metallic flake. So not only is it then insulating for heat, you're looking at additional signal reflection on top of it. And these are things that your average OT guy is really not going to think about. But on the flip side of that, your average Wi-Fi guy is not really going to think about that either. So it's a unique situation when you're talking industry and manufacturing.
Yeah, I mean, and on your dust topic, you even go into like process, oil and gas, extraction, production. All of a sudden, that dust and flake could be combustible. So now you're even looking at the possibility of an explosion depending on the location of whatever hardware you're doing, and extra approvals and requirements for class 1 dip 2 or intrinsic safety to make sure that nothing you're installing there is going to cause a spark that could cause an explosion. So, and like you just mentioned, on those topics, the OT person may have a little bit of detail, but the wireless person, the IT guy at the facility, is going to have little to no knowledge of those requirements from an installation standpoint. They're going to know, hey, we need wireless, but their knowledge is ceiling to floor, in an office building, not control cabinet to control cabinet that may be through, racking, through, you say pulp your paper, or even like the distances required for just a general point-to-point shot. It should just be very, very different from what they're typically used to.
Yeah, it's interesting, but one of the side benefits that a solid assessment can do is kind of start that conversation between the OT and IT groups that traditionally in many sites just constantly butt heads because IT wants it one way, OT is of the opinion, well, that's not going to work here. We have different rules that we have to play by. So a solid assessment can start bridging that gap in communications and help the two sides understand one another, especially when coexistence with other wireless networks is going to be part of the deal. And as we talk about that, and we're talking about the manufacturing floor, what about all of the actual machinery that's doing the manufacturing? You're looking at in pulp and paper, there are drives everywhere, VFDs, fixed drives, and the older models tend not to be shielded very well. And depending on the frequency of the drive, it could be emitting all manner of RF interference from a mechanical perspective. And that's one of the tools in the toolbox of a solid assessment for an industrial and manufacturing environment is going to be spectrum analysis. So you can get a snapshot of that raw RF that, it doesn't care about protocols. It doesn't care if it's 802.11 or 802.15.4 or proprietary, because it's all about those raw RF values that it's seeing in the ambient atmosphere of the site.
Yeah, and that's a great point. Assessments are there to educate and to bring to light things that could cause problems. And in industrial applications, assessments are still fairly new. They've been around for years now, but you go back 10 years when a lot of these facilities are being, an older facility being built. People were just putting whatever wireless system in because it was new. It was the gold shiny thing, right? That was dangling in front of you, the new product. Back 2008, 2009, 2010, in the industrial space, wireless wasn't accepted. It just wasn't something that was trusted. So people were just, as they were getting it, kind of putting it in secret because they wanted to test it out and try it out. And nowadays, that's not the case. People want to use it, but they're not, on the OT side, they're not 100% used to the assessment because that's still fairly new in the industrial space. So, whereas The IT team has been doing it for years. I mean, assessment is part of the process. If it's not done, they don't install it. So having that communication between the two groups can help share knowledge. The IT team has the knowledge of how to do this assessment or knows where to go to get the assessment. The OT team knows of all the requirements for their installation, their application. Do they need hazardous location approvals? Do they need a certain power connection? Do they need a specific mounting? These are all different things that are different that are kind of been a roadblock between the collaboration between IT and OT over the years. Is IT knows one type of product, OT knows a different type of product, and they don't know each other's world. So these assessments now going forward, especially on industrial manufacturing locations, can help bridge that and educate each other.
I think that's the key word there is the education of both sides of the house to understand really what's going on.
Yeah, yep. And in my experience, again, 10, 15 years ago, that didn't happen. IT said the wireless is my space and it's going to be my space. And OT said, you know what, I'm going to do what I want to do then, and I'm not going to incorporate it. And it just causes problems. And now it's more, hey, let's go talk to each other. Let's make sure we're collaborating. And that bridge is being built. It's slower than I would hope it would be, but it's definitely growing,
Yeah.
growing and happening more and more often from what I've been seeing.
Well, and it's interesting because I've been to some crazy sites, and it's I don't know, it's a lot of them are built in kind of a warehouse style, and then you have various lines, production lines thrown in them, but the machinery itself is intricate and it's amazing. But what that also you have to look at is the differences in the types of hardware that you would actually deploy in order to accomplish the wireless project that the site is wanting to do. In traditional Wi-Fi in enterprise, you're looking at ceiling mounts or various wall mounts and whatnot. It's a very standardized practice. But with industrial hardware, it's meant to be mounted on the side of a cabinet or DIN rail in line with other pieces of control gear, which brings up another aspect of power. Traditional Wi-Fi, you're looking at PoE, come running from PoE switches, but the power that's available in most of these cabinets is not going to be PoE. It's going to be low voltage, 24 volt off power supplies, because that's what's pre-existing. That's what's going to fit. It's a lot more difficult to get PoE in cabinets than people usually consider, because the equipment to do so is more expensive. You typically need a stronger power supply, and then on top of that, the industrial switch you put in there, it's going to need to be a more expensive model, which just keeps driving the cost of your project higher and higher.
Yeah. I mean, if you just go away from wireless assessment and whatever, you look at a control cabinet, the biggest things that go into a control cabinet build, whether it's a brand new cabinet or a retrofit, is cost and space savings inside a cabinet. So if you have an existing cabinet or you're building a new cabinet and 24 volts is already there, to add an extra switch or a PoE injector to power a radio, not that it can't be done, not that it's wrong, but it's just an extra cost because you already have 24 volts there. So again, in the industrial space, the 24 volts is probably the more preferred method of power. PoE is okay, it's not a problem. It's just different, and that's just PLCs, drives, not drives, PLCs, HMIs, a lot of that stuff. The inputs and output devices, they're all power off 24 volts. So yeah, that's just kind of the norm in the industrial space.
Yeah, it's just that's a standard essentially.
And you mentioned also, on the IT, the wall mount, the ceiling mount. Again, I think this is changing over the past couple of years, but a lot of those devices are internal mount antennas. So again, their purpose meant to be quote unquote short range. Just again, that's their purposes. Where a lot of industrial, Phoenix has industrial ones that have internal and external antennas. So you have short range, you use the internal antenna one. You need long range, you use the external antenna one, and price wise, they're very similar. So you're not losing a cost battle on changing the hardware type, but you're giving flexibility to the user, whether it's mounted on a panel on the outside, mounted on a DIN rail on the inside, or mounted through the panel. You give options for the customer to take advantage of.
Well, that's an excellent point as far as antennas are concerned, because that's opening up a whole nother can of worms that really nobody in the industrial side is prepared for, because they don't understand the dynamics of antennas and their propagation patterns. And that is something else that an assessment can set straight, for this type of deployment. This is the type of antenna you should use because these are your distances. You don't want something with too narrow of a beam width. You don't want something with too wide of a beam width for whatever given situation. And those can be spec'd out in proper order. I cannot tell you the times that I've gone to a site where the infrastructure is right, the radios are right, the configuration is right, but the antennas themselves are all wrong. They're the wrong type, they're pointed in the wrong direction, they're not deployed properly. That's probably one of the most common mistakes I run across.
The bigger is better, right?
Oh, absolutely. Everybody
Big, big.
sees the higher power value, the greater dB gain, um, and especially in omnis. This is amazing. I've been to so many places where they're trying to push out coverage for whatever devices they have, and they mount their antennas, 25, 30, 40 feet up in the air, and they're strapping on 9+ dB omni antennas. And then they can't understand while they're walking around on the floor why the coverage is so terrible. And it all relates to the assessment and the design and the equipment spec out, because any wireless engineer wouldn't spec out a high dB gain omni antenna to be mounted 40 feet up in the air when all your devices are down on the floor.
Yep. And again, the bigger is better thing is something I've dealt with over the years too. We had an installation, I remember it's been a long time, it was a salt plant, and it was all wireless IO for SCADA, and they did exactly what you just described. They had their main radio antenna up on a building 25, 30 feet in the air, had a 10 dB omni, and couldn't figure out why the radio 10 feet away, 40 feet down couldn't connect to it. It just
Yeah.
wouldn't connect.
Yeah. It's crazy, because really, with your omnidirectional antenna, the greater the gain, the less beam width that you're able to project off of that antenna. So you go from a low gain dB, which has like a emanating kind of a donut shape, to a high gain dB, which is essentially a frisbee, and
Yep.
and these kinds of imagery and explanations really come out strong in a proper assessment and design, to really help the OT guys understand what's being deployed.
Well, again, it comes back to that conversation, right? What are your needs? What are you looking to do? What is your end goal? Right? That's an assessment is not just a document of part numbers and prices, right? So
Yeah, it's much more than just a bill of materials.
you're going to have a conversation with the user. You're going to find out what their need is, what their goal is, what they plan on doing post assessment, right? They're going to any wireless system is a living system. No matter what anybody tells you, it always evolves. It'll change 5 or 6 times throughout the assessment. But even after you're finished, you wrap it up, it's installed, it's working. There's a next step to that system eventually. So yeah, finding out from the user what their short-term goals are, what their long-term goals are, help us as the assessment doers, assessment people, providers. That's a good word for it. You know, we've been doing this for a long time. We've seen a lot of stuff, so we know what works, what doesn't work, what's going to help the user expand their system in the future after we leave, right? Making them want to come back to us for suggestions in the future, or hopefully being able to educate them enough that possibly they can do it by themselves in the next step.
Yeah, providing the right information and guidance is really key. And even then, when you're looking at the individual hardware pieces themselves, making sure that they're going to be able to withstand that environment, what their heat ratings are, what are they IP66, IP67, for environmental, as far as sealing versus moisture and dust, even vibration resistant. And several wood yards that I've been to, they have very large stacker reclaimer devices for wood chips, and they shake, they move, they rumble. They are giant pieces of equipment. You put a standard enterprise radio on that, and within a year, it's going to vibrate apart, because it's just not built for them.
Yeah, I mean, that's not the purpose for it. Like, again, when we build products for industrial environments, you're going to have, like you said, that vibration, but you're also going to have like resonating vibration. Think of a forklift going by, or a train going by that's moving material.
Exactly.
Even if you don't see it shaking, it's vibrating a little bit. I mean, we test things, similar to like you go to Lowe's or Home Depot or whatever, and you go to the paint shop and you have mixed paint and they put in a little shaker thing. When we test products at Phoenix, we have a device similar to that where we put our stuff on a DIN rail, and that's how we test. Shock and vibration is like a paint mixer. It shakes it on a DIN rail, and it just shakes it a lot to make sure it's not going to fall off. We probably test a little more than we should or we need to, but it makes sure that when that truck or that train or that lift is vibrating, the VFD, the drive, it's not going to knock the device off the rail. And again, that's the purpose of the product. We make sure that we can survive in those environments.
Yeah, it's a purpose-built device with these things specifically in mind.
And going back to, like you said, like the location, we're in an industrial automation area. So when you go talking about power, right, 24 volts is what's in the control cabinet. When you go into the control cabinet, everything is not going to be a DIN rail. The amount of times that I've walked into a application or customer and they open the control cabinet, everything's on not on a DIN rail. To the side on the wall, you see double-sided tape and a zip tie with a Best Buy router strapped to the side of the panel.
That always scares me when you see off-the-shelf equipment from Walmart and Best Buy strapped into a cabinet out in the field.
Yeah, so that's DIN rail is again what's in the industrial space. That's what we do. That's how it's mounted.
So one of the other things that we have to take a look at too is the existing wireless that happens to be on the site. Now, you can almost guarantee in just about every site, corporate's going to have their own Wi-Fi out there, in which case that's something you're going to have to contend with, because if you are putting out a general access Wi-Fi for the industrial floor or, anything else, you're going to have to coexist with that pre-existing wireless infrastructure. But it goes beyond just the corporate Wi-Fi. What other wireless deployments do you already have out there? Do you have wireless HART? Do you have any ISA 100 installed on your site? An interesting thing that brings about is transient Wi-Fi. It's something a lot of people really do not take into consideration, and they should. And a prime example of transient Wi-Fi are hotspots on people's cell phones. Now, thanks to the FCC, you can't do anything about that. Marriott tried to do so a few years back, and they got fined by the FCC for their first offense to the tune of $700,000 for them interfering with people's hotspots on their phones. So really the only thing you can do is control that by site policy. Thou shalt not run hotspots. But that's another device that's broadcasting, that's eating up, ISM open channel airspace. It's eating up your airtime. But the other big thing in transient Wi-Fi are fleet management systems for trucks. When you go into, and this never fails, every shipping receiving site I go into where there's multiple trucks in and out, I'll pop open my phone and just look at a Wi-Fi scanner, and it never fails. I'll see PNet. PNet is short for PeopleNet, and it's one of the biggest fleet management packages out there for trucking companies. All these big trucks have these satellite link boxes on the top of their truck, and then they broadcast out Wi-Fi, and it's not just Wi-Fi for the driver to use, but it's connecting various sensors for preventive maintenance from the truck back to a home site so they can plan all their preventive maintenance accordingly for their fleet of vehicles. So that's constant in and out. And I've seen that in pulp and paper. I have seen that in discrete manufacturing. I have seen that in specialty chem. Just about every site I go to, they've got their loading bays. Trucks are in and out. And that transient Wi-Fi is just a fact of life. So that's something else that you're going to have to plan around.
And again, going back to the assessment, that's something that will pop up in the conversation with IT. So you again, as the engineering controls engineer, whatever you want to call it on the plant floor, that's handling that shipping receiving. If you're installing some kind of process that you want to do wireless for that shipping receiving or on the floor, you may not know about that policy for those trucks coming in, right? It's not your job. Why would you know?
Right.
You don't care. So if you're going to be installing a wireless system to help make a process more efficient on that loading dock, and you don't involve all the parties that own the warehouse, own the wireless system, own the relationship with the truck drivers, right? You're not going to know. So once you bring all them together, you bring your IT, you bring the logistics person who handles the warehouse, the logistics person who handles the truck drivers. Now you have this conversation like, hey, here's what we want to do. We want to do this wireless system. And what do you have there that we need to be aware of, right? What are the truckers bringing in? Is there anything the truckers being aware of? What channels are they using? What type of radios are they using? When do they come on? When do they turn off? What channels are you using?
Exactly.
Yeah. All that information comes
Can we
out.
use frequencies that they are not using so that can mitigate that? I mean, there's 100 different things that you can essentially mitigate before the actual installation process ever even begins, because you can pre-plan for it, and you can do that because you've been able to gather all that information in a strong assessment.
Location of those devices, right? I mean, location could cause a ton of problems, even if they're not the same radio technology. Just having something near your radio that's overpowering it could cause. I give the example of you and I are talking on a driveway, right? We're having a conversation, and the neighbor's riding mower comes by. It's a loud noise. We can't hear each other. We're retrying. We're stopping. We're pausing. Our conversation takes longer. That's fine for us, general purpose, but for an industrial automation system, that could be the difference between a process starting and a process stopping, and all of a sudden they're down and we're losing money. So, understanding what's around us, the times that things are going to work, maybe the times the trucks are coming in to do receiving, when they're going to be loading and unloading. I had a customer at an automotive location years ago that did end-of-arm tooling for automotive. So they wanted to get rid of all the flexible cable between the PLC and the end of arm. So they put a Wi-Fi radio at the PLC, a Wi-Fi radio on the end of arm, and it was only going like 15, 20 feet, really short. So Wi-Fi is perfect. It worked great, fantastic. They said randomly it would just fault. We couldn't figure out why it would fault. It would run for days, and then randomly in a day it would fault 2 or 3 times and it would stop. Couldn't figure it out. So we ended up going out, and one of our engineers sat there for 2 days. The first day, nothing happened. Ran fine. Sat there all day waiting for it. Second day, 10:30 in the morning, boop, faulted. Had a wire capture running, and what they found is at 10:30, 12, and 3:30. What are those times of the days?
Oh, break times, yeah.
Break time and lunchtime, right? Break time and lunch. At break time and lunchtime, IT had a pre-scheduled access point that turned on in the break areas, which are right next to where the robots are running. And depending on the dynamic channel selection it picked, it would pick the same channel as our robot, and you would just see all the Facebook traffic, all the YouTube, all the workers going on to the internet during their break caused enough delay on the channel that would fault the robot.
That's interesting. And had they had an assessment prior to, they may have been able to catch that ahead of time.
Yep. And it was one of those things where it only happened randomly, because depending on the channels on the other access points for the enterprise network, it may pick a different channel, but it just happened to be randomly. So we ended up talking to IT, and they gave us 3 or 4 channels, and they disabled them on all the access points in the area, and never had an issue with it again.
That's interesting, because had that conversation taken place prior to the installation, that entire situation could have been avoided.
All the time from a Phoenix standpoint, all the time from the customer standpoint of just, again, standing around for a day and a half waiting for the problem to happen was.
Well, the frustration of the troubleshooting of a problem that seemed to be happening randomly.
And again, time is money, right? So it was a paid service trip for our guys. So they paid 2 days for our guy to sit there, and wait. And we had to have a person guiding us, because it was an automotive manufacturing facility, so you can't just walk around.
Right.
So they had a guy or two to standing around all day doing it. So they lost 2 day and a half of salary of a guy to standing there, bringing us around.
Yeah, the hidden costs of downtime can be immense in most manufacturing.
And that's one thing that's lost on assessment costs. Again, with industrial situations and systems, or the industrial area, assessments are still new, and the sticker shock for an assessment can be large to an OT engineering manager or that group, because it's thousands of dollars, but it's assessment. It's a lot of information, it's a lot of time. What's not compared is, hey, that assessment, which is going to get rid of all these risks long term, versus what happens if this line is down for a half an hour, a day, and how much money are you losing if that happens?
If you go in blind with an install and don't pay attention to these things. No, I totally get it. One of the biggest things a solid assessment can do is mitigate those hidden costs, downtime and troubleshooting, and bringing other people in to look at your systems. So no, I totally and completely agree with that. I'm sure we could talk multiple examples of what had an assessment been done, the dollars and cents that could have been saved, let alone the personal frustration on top of that.
Yeah, and people like yourself, myself, the engineers from every manufacturer does wireless. They have that experience because they've lived through it. They've lived through this should work, but it didn't, or this doesn't work and it did. And that's the knowledge they bring to that assessment conversation that can help mitigate those risks.
Yeah, I was at a site that was a smelting facility, and it processed zinc ore and turned it into actual ingots that then could be sold to customers for whatever purpose. And so it would create ingots that were like 5 pounds that could be carried in your hand, but it would also do massive blocks of 2 and 3,000 pound ingots of just pure zinc. And they were wanting to introduce safety sensors on their employees that worked around the smelter to detect overheating and various other chemicals in the air and things like that, because they wanted to protect their employees, not only their health and well-being, because they didn't want anybody passing out on the job or overheating, but also from an insurance perspective, it made dollars and cents for them because it would drop their premiums because they were being proactive for employee safety. Originally, they tried to go in blind with some of these sensors, and they would work half the time and they wouldn't work. So they contacted us, and I went out and I did an assessment. I ended up doing an assessment of their entire site, but that particular building, what I found before I even fired up my systems, I knew as soon as I walked in, I'm surrounded by stacks and stacks of metal. And not only is it stacks of metal, it's changing stacks of metal. The reflection was just off the chart when I started doing a passive survey, and you could just see the irregular patterns form. It was just insane. So once I was able to really show them what was impacting, we were able to modify their design, adjust power levels, and change some frequencies a little bit, with channel space. We were able to make that body sensor, the body track system, a success. But had they had that assessment first before just blindly going in and trying to use these, they would have saved a very expensive trip for me to go out there, because this was 4 states away and I was there for almost a week. And so the initial cost of that project with those sensors and the AP they put up and everything was relatively inexpensive. But the hidden cost of not following the proper procedures first really got to them. But now they understand that, and it's sometimes it's a hard lesson to learn.
It is. I mean, you mentioned two things that caught my ear. The reflections. Again, you're a controls guy who doesn't deal with wireless. You have no idea that that's even a thing. And in a changing environment, again, you have these big stacks of ore moving around. So, the impedance in one place one day is different than the next day. The impedance is higher, it's lower, it's a different spot. You have racks and racks of storage that are changing. Those are things that people like you and I already have in our heads when we're going to do an assessment, that people that have no experience don't even know it's a thing. So again, where we look at the assessment and the amount of time it takes and the cost that goes into it, it's an investment, but it's an investment in your future of your application and your system to make sure it works the right way, and you don't miss things that people like you and I are going to be thinking about.
And it's interesting too, because then it becomes a really solid educational tool for the people on site. Because once they experience all of that, it'll stick, and they'll say, they may not remember exact details, but they can remember enough to go look it back up on the assessment. What was causing this? What was causing that? Why did we do this? Oh, it was to mitigate this issue. That's why.
Yeah. And the other thing with all that assessment, the amount of times that I've been called from a customer and go, hey, I want to install the wireless in my facility, right? Can you come and help me? And I go, well, what do you mean by the wireless? Well, yeah, that Wi-Fi thing. You mean Wi-Fi? You install Wi-Fi? And okay. Well, what are you looking to do? And have you looked at other wireless technologies as well for your application? Oh, there's more than Wi-Fi. They don't even know that there's different
Yeah, totally.
between different technologies and their project needs, and the differences and the questions to ask before you even get to what product you're going to be picking.
A big part of when I go in to do an assessment is I ask specifically, what type of project is this going to be for? What are we hoping to accomplish? What's the end goal of this? Especially if we're looking at a mesh style deployment. Industrial radios many times are purpose built not only for their environment, but specifically for different types of topologies. And a big one is mesh, especially for roaming robots that are performing different functions. This really takes, roaming, which can be an issue in standard Wi-Fi, to a whole different level, because now it's not you worrying if, employee X's phone is going to become a sticky client and stuck to one AP as he walks through the office. But it's a whole different ball game if your robot that's trying to move stock around your warehouse is not roaming as it should. The difference here, we're not talking about radio device and then, odd client device. We're talking about radio device and then a specialty radio device that is installed on that robot that you can then predetermine how roaming is going to work through the various configuration settings. Because, if that is your end goal, is the most solid roaming you can get for these bots on your floor, that's completely different than, well, we need this mesh self-healing topology for sensors, but these sensors are stationary. That's going to be two different technologies. Even though they're both mesh topologies, it's going to be two different wireless technologies backing them up.
True, and then, people talk topology, they don't necessarily think to talk, connection medium or how far they need to go.
Right.
Like a lot of users don't understand there's a trade-off between like data rate and distance. The different technologies.
That is excellent point, and that's one of the things you really have to drive home.
Yeah. So, I mean, like people just see the new fastest radio. That's the one I need. I need the fastest, the newest one, and
bigger, better, faster, more. Right.
Bigger, yep. And once you start having conversations, especially on plant floors, maybe it is wireless Ethernet. Maybe the connection medium is Ethernet, but there's still a lot of serial out there, RS-45, RS-232, a ton of it. I mean, I can't tell you that there are wastewater plants that still run these serial-based PLCs and they're stranded. So they're out there. Someone's still going around in a truck from place to place and recording stuff. So we still get into a lot of long-range serial communication, panel-to-panel control or panel-to-panel communication, where they want to network it, but they didn't define what network the panel means. Network could be an Ethernet cable. That's what everybody jumps to when they hear network. But it also could be, well, what's in your control cabinet? Is it an Ethernet cable, or is it a digital on-off? Is it an analog for a level sensor, a float sensor, a proximity sensor, the cabinet open or closed? If it's just that kind of stuff, you may not need a.
Well, that's essentially wireless I/O, correct?
Wireless I/O. So you don't need the shiny fastest thing, because that I/O is bits and bytes, not megabits. So there could be a better solution for maybe what we call a cable replacer for I/O. It's you bring I/O into a radio, it's a wireless cable to another radio, and it comes out exactly the way it came in. And whether you're going 100 feet or you're going a couple miles. So maybe that solution was better, and they didn't even know it existed.
Well, yeah, and even then you're saving latency, because when you're using wireless I/O versus trying to convert it to Ethernet, you're not losing latency in that conversion process, and you're not adding additional equipment and cost and expense on top of that, because you're transporting it wirelessly in its native format.
Yep. So I mean, the assessment conversations, when I come in and go, he mentioned what are your goals, and then what are you looking to do in this app, in this solution? What are your goals? Okay, so now what are you connecting? How is it connected? Well, these things have analog. This is an Ethernet connection. These couple have serial. This is in that place. This is in this location. And now people like you and I, who have a broader background on what technologies and what equipment are out there, we can go, okay, maybe it's this one platform solution and we add some intermediate gateways or whatever to keep it all one system. Or maybe it's better that we keep this portion of the network on this platform and we do these portions with a different connection medium on this platform, and they coexist side by side, right? We can look at all the different solutions versus the new shiny nugget that's dangling on the internet at the top of Google search, right?
Absolutely, absolutely. The latest buzzword of the technology is always what's on the forefront of people's mind, because that's what they're seeing blasted out everywhere. Well, it goes back: bigger, better, faster, more, right? The American way. But it's interesting when you look, because all of these, while using different protocols, they're all still using the same RF space, and that's really where spectrum analysis becomes a very important piece of the assessment puzzle. So you're seeing what's actually happening in the ambient RF. And so that needs to be a strong portion. It's also very visual, and it can, a picture's worth 1,000 words, right? You can place forward your visuals. This is when your drives kick on, and you can see how it's interfering with your current wireless infrastructure. We need to avoid that space when these drives kick on. So let's use this channel infrastructure. Let's move to 5 gigahertz. Even now with the advent of Wi-Fi 6, that's opened up 6 gigahertz. It's only a matter of time before industrial radios also start using that channel space. These different things you're not going to get if you go and just install something blindly. That's all part and parcel of a solid assessment for your project.
Yep. And again, I mentioned that lawnmower analogy earlier. Just because they're on different frequencies or different channels, whether they're Wi-Fi, non-Wi-Fi, Zigbee, whatever, if one of those things are transmitting strong enough, they're going to cause issues if they're not deployed right. Whether it's a configuration issue or, sorry, not an issue, misconfiguration or a misinstallation, your antennas are too close to each other and one's just overdriving the other. I had a conversation with a customer years ago where we had a simple point-to-point application across a lake, and it was just sending from the top of a water tower to a SCADA system for the flow and the level of that water tank. And they called us and said, hey, this is working great, but it just randomly drops out. And the first thing comes to my mind is water tower cell antennas. That's highest point, water tower's up on a hill, highest point in the area, antennas. And I go, hey, any chances of wireless installed in that tower? And he goes, no, nothing's up there. And I'm like, maybe we should go check on that. You should go back and ask. So I get 2-3 weeks later, get an email from him, see the attachment in the email. I wonder what this is. Open the email. He goes, hey, yeah, there's some wireless on there. See attachment. I open it up. There's an arrow pointing to our antenna, the top of the water tower, right in the middle, and circling our antenna is just T-Mobile cell antennas in a complete circle around the water. So anytime emergency responders keyed up, an ambulance, police officer, anything keyed up to those things, 30 watts of power were keying up around and it was completely different frequency, but so much energy.
What frequency was your deployment?
Ours was 900 megahertz. So
900. Oh, well,
1 watt.
Yeah, that makes sense, because the 902 to 928 is what you were allowed to use all around that 902, both above and below. That's all cellular space.
Yep. And really, really high power. So basically what they had to do is they had to go back out there, climb the tower, pull that antenna down, and drop about 20 feet, 30 feet below, which is still plenty high, below those antennas. And they hadn't again, a survey, a free look at the tower, conversation with people would have resulted in that never happening.
Yeah, absolutely. Because you would have known prior to that, hey, we don't want our antenna up there with all that cellular activity. We want it drop down.
It comes back to in education too. Like the guy just was unaware, the installer, the customer was unaware that on a water tower, cell antennas go up. So
right.
Just, you and I, if someone said, hey, we're going to put an antenna on a water tower, the first thing we go is, hey, 10, 15, 20 feet away from any cell antenna, we need to get away from it, right? That's just general practice. So if you don't have that, we can't use it. Just, again, things that you learn over the years that a general user may or may not think about.
Yeah, it's interesting too, especially when you look at sensor packages and wireless IO, and because it's you mentioned earlier the trade-off of speed versus data rate versus what you actually need and what are you trying to transmit. these other protocols and these proprietary protocols for a lot of these sensor packages, they're very robust and very low latency. Now, granted, their data throughput is absolutely minimal. It's in kilobytes, it's not even in megabytes. And a lot of people see that and they're like, well, is that even enough
Hmm.
throughput to get the job done? Well, the vast majority of your transmissions are a short burst of a few ones and zeros, and that's it. So what they're transmitting is in the K, not even the KB, but it's all about that
Hmm.
stability and it's all about that reliability and it's all about that low latency to get that communication there in time. So, it's also kind of a different rule set that you're playing by versus standard general access Wi-Fi.
Well, yeah, I mean, you're sitting here, we're talking on a podcast right now. We're streaming megabytes of data, so we need that high throughput. You're putting a sensor on a 1 million-gallon tank that's holding water. If that level changes too much in 5 minutes, we have a really, really big problem, right? So you don't need that level
Right.
every second. You shouldn't need it. You have secondary sensors that are reporting back, maybe over a wire or something, that are reporting back in case of a leak. But if that level sensor that you reports back every 5 minutes is changing way too much, it's a huge, huge problem that is not the wireless system's problem.
Absolutely. Setting up those response times. How often do you want that information? Because then you're looking at, well, am I going to use, do I have fixed power out there or am I going to use a battery powered solution? And being able to present those options to the client so they can understand that better is just another solid piece of an assessment.
The trade-off again, there's also so many wireless technologies that are coming out here that are low power, but they're not meant to be on all the time. They go to sleep, they come up, they transmit the electricity. That's where you get the battery and the solar power stuff. If you want something that's transmitting over and over and over constantly, that's typically not going to be a battery powered solution. You're going to need line power. And again, things that are considered during the assessment, they go, hey, you want to install something at this site. Do you have power? Do you need power? Do we need solar? Do we need a battery? How often do you need this data? Those are all things that come out during this assessment that they may or may not think about. They just go, I want the wireless out there.
Well, and that's true because if there is no power out there and you need steady streaming data, so you have to get power out there, what's the added cost of running fiber at that point? Is wireless even the ideal solution at that point if you have to hardline power out to that particular site in the first place?
I sold wireless for 10 years. And again, my answer was, if you can wire it, wire it. Why, if it's there and it's not cost prohibitive, wire it. I mean, I'm not going to sit here and tell you that you shouldn't wire it. That's the generally speaking the better solution. If you can put a cable into it, that's going to be the most reliable solution. Not saying that wireless isn't reliable, but it just is. Common sense is you have a cable that's wired in. As long as no one cuts the cable, you're fine. Is that an option? That's a great point. Is that an option? And again, it can come out in the assessment that we can't get power out here, or we can't get the power you need to run a wireless system. That maybe either A, you can't do it, it's just a no, we can't do anything, or B, here's the cost it's going to take to do what you need to do.
Right. So from an assessment point of view, let's take a look at kind of the pros and cons of an assessment. Let's plus delta this out and let's start off with the cons list first. And I spent a lot of time thinking about this, and really the only kind of solid cons that I could come up with are basically two issues that you're going to have in any project regardless, and that's cost and time. There's an additional cost for your project when you include the assessment, and it does extend the
Mhm.
time to a degree of your project completion. But that's really all I could come up with as far as even kind of a negative to that.
I'd agree. I mean, the cost portion, I think, is becoming less of a con. I think it's just more of an unknown, and it's a surprise, right? So it's a con because it's a surprise. They're not used to it. Again, back 15 years ago when we first started coming out with radios, industrial radios, we would come out and do the services for free because we were trying to prove. Well, again, in the industrial spaces, assessments weren't structured right. We didn't know how to do them. They just weren't there. So we'd go out and we'd do it for free just to prove that our stuff was reliable. In the enterprise space 15 years ago, it was normal. That's what you don't do a wireless deployment without an assessment, period. in the industrial space, it's getting more and more known. We do them all the time as a service for a charge, just like you would see in an enterprise space. And I think it's just the industrial space is still catching up a little bit to the enterprise space. So it's a con, but it's more of a surprise in my mind. Time added, yep, I agree 100%. And the other one, I would possibly pop in there as more of, again, just a triple asterisk as it's a con, but not really a con, is possibly the change in the solution from what the user wanted or expected to what we provide them. Take the shiny new object. They want the cool new product that's brand new out there. That's all they're thinking about, is that the solution is going to be. And then our assessment comes back and goes, hey, you know what? That may not be the best solution. We can use it in some places, but here's what we recommend. And that could cause, again, some conversations and some pushback because they want to go one way. Maybe it's a vendor they want to go with too. Maybe you suggest a certain vendor and they go, well, I really don't like that vendor. I want to use this vendor, and which could be okay, or it could be this vendor does a little different. So this is why I selected this vendor versus that vendor. So that would be the only other con or prawn or kind of pro con. It's not really a con, but it's just one of those things that I've had come up, or I've changed the solution on a customer because I felt there were some benefits to changing the product.
So, well, we'll stick with a plus delta then. We'll call that a delta, since it's not really a con, but we'll call that a delta, right? So let's look at our pros. Let's look at our pluses, right? A big one that we kind of touched on earlier is it does facilitate communication between OT and IT. Additionally, it helps facilitate coexistence with all the other wireless that's already there, anything pre-existing. Because how often do you get a greenfield environment where there's nothing and you're starting from scratch? I think in my 20 years of wireless in general, I have gotten to do maybe 3 or 4 greenfields. That's about it. Everything else has already had something pre-existing. Another positive is, yeah, you're spending some money up front, but long term, it's going to save you money and heartache. We've already discussed a few of those use cases where, it involved us, and we knew that, going into it, had they had this assessment first, they would have saved thousands and thousands in hidden costs, especially in not only in just downtime and the things that are tangibly calculated for them, but the cost of someone like us coming to site and being there and trying to catch that random issue, and spending that time, because that can be a sizable cost over time to try to fix that they could have avoided completely had an assessment been done from the get-go.
Agreed 100%. And I'd add to that all is the relationship between IT and OT. Again, I still look back, and it sticks in my head over the 15 years I've been doing this, is that, when I first started, IT wouldn't talk to you if it wasn't, one of the top 3 enterprise vendors you were installing. It wasn't, the answer was no. Like it was their domain, rightly so. I mean, they had all the knowledge. I mean, that, rightfully so. They're protecting their space, what you do now, security, they're protecting everything. Doing the assessment, bringing all the parties involved up front, alerting them to what you're doing. Like we talked about, having a meeting with IT and going, hey, here's what we're planning on doing. Here's how we would like to do it. And what are you doing down there already? Maybe we can collaborate. Maybe there's already infrastructure there that we can take advantage of that we can save some money on. And then long term, that relationship builds. You guys collaborate more. The people at the top that are paying for it all see the collaboration, seeing that you save the money. So they're now open to allowing you to have more projects so you can get more done, be more efficient. So it's a long stream of positives if you have that open communication channel. The amount of times that I've recommended to customers, hey, you're going to do wireless on a plant floor, you might want to bring IT in. They go, don't want to do that.
We don't really want to involve them. And when it comes to something like this, you need to, because they have systems, you have systems, and they got to live together.
They come back a month and a half, 2 months later, something's installed, and I get on the phone, and the IT guy's there, and I'm like, told you we should have done this earlier. But now we're in that situation where the project timeline's being delayed. Our customer's not getting paid because the customer's not paying them because they have a solution that's not corporate policy wise. The conversation up front, 9 times out of 10, when you bring everybody involved in the beginning, everything goes smoothly. When you try to go around the side and ignore certain people, it causes tons of problems.
Yeah, it's It's really unfathomable sometimes when you think about how much heartache can be avoided from the get-go when you do things right the first time.
Yep. This sticks out of my head. I was doing an installation for an automotive customer years ago, and it was the 900 megahertz radios we were talking about on the roofs. They're networking air handlers. So, hey, turn the air handler on, report that it's on. So digital input back and forth, and the current draw of the air handler. So nothing, we're talking about small bits of data, but they had, it was on a roof with 80 different air handlers, 4 different hubs. So 4 hub and spoke type systems, 900 megahertz IO, very simple, going back to the building automation system. In the beginning of this conversation, we're talking, and I'm like, hey, I know your facility. I've been there before. Do you want to involve your IT or your wireless groups in this? Oh, no, we're fine. We know what we're doing. I'm like, all right, I'm just bringing it up now, just so I've been there. I've talked to them. I kind of know. I've been through it before. Nope. So we do some general path studies, make sure it all works. Everything works great. They buy for 4 different facilities, 300 radios over 4 different facilities, install them all on the roofs. Everything's working great, no problems. Fast forward a year and a half, I get an email from our sales person with the integrator installed them, going, hey, this customer wants to have a meeting about the wireless we installed on the roof. And I get on, it's their industrial wireless group director. And he's asking me all these questions about what the radios are, how they work, why they're there. and fortunately enough, that the end customers, people that we had worked with back years ago, were there too, as well as the installation integrator. And I go, hey, here's how they work. This is what they do. I can't answer to you while they're there. I'm a component manufacturer. They built a solution, and Jim and John, which aren't their names, from your company, are right there. They'll be able to answer that question. And basically, what was happening was, because we were a 1 watt 900 megahertz radio, and the roof to the plant floor was only about 50 feet high, the radiation from our roof was bleeding down into the plant floor and interfering with the sensor network, the LoRa sensor network they had on some of their systems, because we were line powered 1 watt LoRa's, milliwatt power.
Oh, wow.
Still long range for wireless, but so they were very frustrated that these systems had gone in
right
and been installed without them knowing. They were almost to the point of ripping it all out, and it ended up getting resolved. There was conversation, but again, policies rewritten that any wireless that goes into the facility has to go through that group, and they have to get approval and go back in time 3 years or however many years it was when we first started the conversation. If they would just would have gone and had that conversation up front, we would have mitigated all of that time. So we spent 4 or 5 hours over 3 or 4 different days on calls discussing this. Their team spent more and more time in meetings. So they probably spent 2 business days worth of time dealing with something that could have been mitigated up front. Now, 3 or 4 or 5 people.
I wonder what the hidden costs of that and the lost production of all the people that were involved in that. That'd be interesting to find out.
And that's not even to say how long it took them to identify what the problem was. That was after they identified where the problem was coming from.
Right.
Days and weeks that sensors were going down. They didn't know what it was. They identified it already.
And then trying to figure out a mitigation strategy on top of that.
Yep. So again, that relationship between the building management and the OT and then that wireless group is probably building it up. It was probably hurt. So again, that's what I stress the most. Any wireless system you're going to be installing with an assessment is involve all the parties, because it's not going to save you time, money, and everything. It's going to build a relationship between all the groups in your facility, make things just work much easier, much nicer. And like I said before, it's going to make the people up top that are paying for it like you more too. So that leads to more perks in your career as well.
Well, and those relationships that can be built off of this, those are invaluable. You can't put a dollar figure on those. You can't put a dollar figure on the goodwill between 2 teams that makes it easier for them to work together.
Time and money is a big thing, but yeah, that relationship and that collaboration is what makes everything work.
Well, we've covered a lot of material here. Really, all of the unintended positive consequences that can come out of an assessment are fantastic, on top of the actual intent behind it for whatever specific project. I think this has been a great conversation. Thank you so much, Justin, for coming and hanging out with me today. Hopefully we can have you back again soon and talk about more good stuff here on the Industrial Wi-Fi Shop.
Yeah, thanks for having me, Scott. honored to be your first guest on your podcast, and I wish you good luck with all of them in the future.
Thanks for listening, everybody, and we hope you join us on our next episode of the Industrial Wi-Fi Shop.